Good morning to everyone. I am Shweta from GMRP Gajwal. So in this video lesson, I am going to discuss about concepts of transmission lines and waveguides. The subtopic is different types of transmission lines. So in this class, we are going to discuss the introduction to transmission lines and different types of transmission lines. In that, we have a parallel transmission lines, twisted pair transmission lines, coaxial cable, waveguides, fiber optic cables are there. So first of all, introduction to transmission lines. So here the transmission lines are used to transmit the message from one end to another end. Okay. So in the field of electronics and engineering, it is needed to guide the electrical energy from one point to another point. So one form of electrical energy is in a RF signal. It is required to guide the RF signal from transmitter to antenna. So here the guided media is known as a transmission line. So here the transmission line must guide the RF signal from transmitter to receiver or antenna with the least possible power loss. So the loss of power by guiding the RF signal will depend on the special physical and electrical characteristics of the transmission line. The physical characteristics included the length, area of the cross section, and the number of conductors, so etc. of the transmission lines. Whereas the electrical characteristics comes under resistance, inductance, capacitance and conductance along the line. These transmission lines are suitable at PF frequencies also. The traditional transmission lines at high microwave frequencies cannot be used here. So hence the special type of guided media to be used at these high frequency signals. So such media are known as a waveguide. These waveguides are used to transmit the microwave signals from one point to another point with less power losses. So the examples for this transmission lines are telephone lines. This is used to transmit the voice information from one end to another end, and it uses the radio frequencies also. These are used to transmit the power from transmitter to receiver. So like this. Okay, so we have different types of transmission lines are there. So one of the example for this type of transmission line is parallel wire type and coaxial lines are examples of transmission lines. So these are the examples of transmission lines. So coming to the limitations of transmission lines, these are used at low frequencies and are lossy at microwave frequencies. Okay, so here the transmission line is used to guide electrical energy from one point to another, and it is used to transfer the output, that is RF energy of a transmitter to an antenna. This energy will not travel through the normal electrical wire without great losses. So the antenna can be connected is usually some distance away from the transmitter. So or the transmitter is located inside a radio room and its associated antenna is mounted on a mast. A transmission line is used to connect the transmitter and the antenna. So here the purpose of the transmission line is to transfer the energy output of the transmitter to the antenna with the least possible power losses. Okay, so the transmission line consists of a resistance, inductance, capacitance and conductance. Okay, so we have a different types of transmission lines, that is 5 transmission lines: parallel transmission line, twisted pair transmission line, coaxial cable, waveguides, fiber optic cables. So first one is a parallel transmission line. Okay, so this parallel transmission line consists of a 2 wires that are in parallel. Okay, so here the parallel transmission line consists of a 2 wires that are in parallel. So that's why these transmission lines are called as a parallel lines. Okay, so mostly these parallel transmission lines are used for the power lines, telephone lines and used to connect the television receiving antenna to a home television set also. Okay, and this line consists of this line consists of 2 wires that are generally spaced from 2 to 6 inches apart by insulating spacer. Okay, so advantage of this type of transmission line is simple construction, but coming to the disadvantage, it has a high radiation losses. Okay, so it has high radiation losses. To reduce the radiation losses from the cable and interferences, grounded shield can be placed around the cable. So here we have to place a grounded shield so that we can minimize the radiation losses. So here this field will place no part in transferring the signal from source to destination. Its only the function is to reduce the noise and interferences. So another type of parallel line also there, that is 2-wire ribbon line. So this type of transmission line is used for the television receiving antenna to a home television set. Okay, next one is a twisted pair transmission line. Okay, so here as the name says that the line consists of a 2 insulated wires twisted together to form a flexible line without the use of the spacer. So here we are not using any spacer. Okay, so only we are using a 2 twisted pairs. Okay, so it consists of 2 insulated wires twisted together to form a flexible line without the use of the spacer. It is not used for the transmitting high frequencies because of the high dielectric losses that occurs in the rubber insulation. Okay, so we have 2 types of twisted pair transmission lines: unshielded twisted pair and shielded twisted pair transmission lines. So these twisted pair transmission lines are used for the voice communication in telephone systems and also data transmission of up to 100 Mbps nowadays. So main usage of this twisted pair transmission line is telephone systems. Okay, so because these lines will carry both voice as well as data. Okay, so next one is a coaxial cables. So the coaxial cable or coax has an inner conductor that is surrounded by an insulating layer that is surrounded by a outer conducting shield, and the outer conducting shield is also enclosed. So once you see this, by this we can easily say that. So here the coaxial cable or coax has a inner conductor that is surrounded by a insulating layer surrounded by a outer conducting shield, and the outer conductor is also enclosed in an insulating shield, and the whole cable is protected by a plastic cover that is jacket. Okay, so here the design of coaxial cable gives it the high bandwidth capability. The coaxial cable is used as a transmission line for radio frequency signals. Its applications includes feed lines connecting radio transmitters and receivers with their antennas, computer networks, that means internet connections, and distributing cable television signals also. We use this type of coaxial cables. Okay. So here the design of this coaxial cable will give a high bandwidth capability. Okay. So next one is a waveguides. So waveguides are hollow metallic tube for transferring the electromagnetic energy. So here the waveguides are normally used as a transmission lines for the frequencies above 1 GHz. So for the frequencies above 1 GHz, if we want to transmit, we have to use waveguides. Okay. So here the waveguides are a hollow metallic tube for transferring electromagnetic energy. Waveguides are essentially a coaxial lines without a center conductors. We have different types of waveguides: elliptical waveguides, circular waveguides, and rectangular waveguides. So coming to this waveguides are more efficient than the two-way transmission lines and coaxial cables because of this low radiation losses. Because of this low radiation losses, we use this in easy transmission. Waveguides can handle more power than the coaxial lines of the same sizes. Waveguides are normally used as a transmission lines for frequencies above 1 GHz. Okay, and waveguides can also be accessed as high pass filters. Coming to fiber optic cables. The fiber optic cables are used to transmit the information in the form of light. In the form of light, we will transmit the information in the form of light only. So here the cables are more advantageous over the transmission lines. It has high bandwidth and carrying the information capacity is also high. High speed, more security, small size, and less in weight. Fiber optics. Here the fiber optics are pure glass about the diameter of a human hair. They are arranged in bundles called as optical cables and used to transmit the light signals over a long distance. Hundreds or thousands of these optical fibers are arranged in bundles in optical cables. The bundles are protected by the cable's outer covering shield called as a jacket. So here we have a core and cladding are there. So coming to the applications of fiber optics: cable TV systems, communication networks for LAN and MAN, local telephone and long distance telephone lines, secure communication systems of military bases, closed circuit, that means CCTV systems, and the telecommunications, Ethernet and gigabit Ethernet, aircraft communication, college campus communication, under ocean communication. So for each and every communication system, we use this type of optical fibers. Okay, these are the applications of optical fibers. cable TV systems, communication networks, local telephone and long distance telephone lines, secure communication systems of military bases, closed circuit, that is CCTV system, telecommunication, Ethernet and gigabit Ethernet, aircraft communication, college campus communication, under ocean communication. So each and every place we use this fiber optic communication. Okay. So we have discussed about, in this class we have discussed about the introduction to transmission lines and different types of transmission lines. So just once again we'll look after the same topic so that you can easily understand. So coming to the transmission lines. So first of all, what is a transmission line? Okay. So transmission line is nothing but it is used to transmit the message from one end to another end. Okay. The example for this transmission line is a telephone line, and it transmits both voice information from one end to another end. It uses the radio frequencies. Okay. Next. So in the field of electronics and engineering, it is needed to guide the electrical energy from one point to another point. So one form of electrical energy is here RF signal, that is required to guide the RF signal from transmitter to the antenna. So the guided media is known as a transmission line. The transmission lines must guide the RF signals from transmitter to the antenna with the least possible power losses. Okay. With the least possible power losses, we transmit the information or energy or power from transmitter to receiver. Okay. So here the transmission line must guide the RF signals from transmitter to the antenna with the least possible power losses. The loss of power while guiding the RF signal will depend on the special physical and electrical characteristics of the transmission line. The physical characteristics include the length, area and cross section and number of conductors etc. of the transmission line, whereas the electrical characteristics are resistance, inductance, capacitance and conductance along the line. So these transmission lines are suitable at PF frequencies. The traditional transmission lines at high microwave frequencies cannot be used. Hence, the special type of guided media to be used at these high frequency signals. Such media are known as waveguides. So waveguides are used for above 1 GHz frequency signals. We use a waveguides. Coming to the transmission lines, for below 1 GHz frequency signals, we use a transmission lines. These waveguides are used to transmit the frequency signals from one point to another with less power losses. Okay. So we have different types of transmission lines. That is parallel transmission lines, twisted pair transmission lines, coaxial cables, waveguides, and fiber optic cables. Okay, parallel transmission lines, twisted pair transmission lines, coaxial cable, waveguides, fiber optic cable. Okay, so first one is a parallel transmission line. So it consists of two wires that are in parallel. So one, see here, here we have a two wires that are in parallel. Okay, so that's why we call it as a parallel transmission lines. So these are used for the power lines, telephone lines, and used to connect the television receiving antenna to a home television set. Okay, so these lines are used for power lines, telephone lines, and television receiving antenna to a home receiving set. Okay, so in a parallel transmission lines, the advantages of this parallel transmission lines is simple construction. Coming to the disadvantages, high radiation losses. The radiation losses can be reduced by using a can be reduced by grounded shield can be placed here. So here we place a grounded shield. By using that, we can reduce the radiation losses. Okay. So we have another type of parallel lines also there, that is two-wire ribbon line. This type of transmission line is commonly used to connect the television receiving antenna to a home television set. Next one is a twisted pair transmission line. So here also, as the name implies, the line consists of two insulated wires fixed together to form a flexible line without the use of the spacer. It is not used for the transmitting high frequencies because of the high dielectric losses that occurs in the rubber insulations. Next one is a coaxial cable. So here the coaxial cables or coax has an inner conductor that is surrounded by an insulating layer that is surrounded by a outer conducting shield, and the outer conductor is also enclosed in insulating shield, and the whole cable is protected by a plastic cover that is a jacket. So here the design of coaxial cable will give it the high bandwidth capability. Here the coaxial cable is used as a transmission line for radio frequency signals. Its applications includes the feed line connecting radio transmitters and receivers with their antennas, and computer networks, that is internet connections, and distributing cable television signals also we use these coaxial cables. Coming to the waveguides. So here the waveguides are hollow metallic tube for transferring the electromagnetic energy. These are normally used as a transmission lines for frequencies above 1 GHz. For frequencies above 1 GHz, we use this type of waveguides. So we have three types of waveguides: elliptical waveguide, circular waveguide, and rectangular waveguides. Okay, so these waveguides are more efficient than the two-way transmission lines and coaxial cables because of low radiation losses. The waveguides can handle more power than the coaxial lines of the same size. These are normally used as a transmission lines for frequencies above 1 GHz. Okay. Next one is a fiber optic cables. These are used to transmit the information in the form of light. Okay. So this is a fiber optic cable. It has core and cladding at this place. This is a core and cladding that is surrounded with a jacket. optic cables has more advantages over the transmission lines. They are high bandwidth, carrying the information capacity is also high, high speed, more security, small in size and less in weight. So coming to the applications of fiber optics, cable TV systems, communication networks for LAN and MAN, local telephone and long distance telephone lines, secure communication systems of military bases and closed circuits, that means CCTV systems, and telecommunications, Ethernet and gigabit Ethernet, aircraft communications and college campus communication and under ocean communication. Okay, so we have these type of applications are there in optical fibers. By using of optical fibers, applications will be less, more, but disadvantages of this fiber optic cable is only the cost is high, but otherwise applications are more rather than these transmission lines. Okay, we have discussed about the introduction to transmission lines and different types of transmission lines. In the next class, we are going to discuss about the equivalent circuit of the transmission lines and primary and secondary constants of the transmission lines and group and phase velocity in transmission lines. Okay, these topics we'll discuss in the next class. So coming to this topic, write these two questions as assignment, that is list different types of transmission lines and explain different types of transmission lines. In this you just mention the different types only, but here you have to explain the types of transmission lines, each and every one. Okay, thank you.